start.
Amazing.
So, what I got for you is, this is called an applet, which is kind of easy. And what kind of curve would you call this?
Normal.
Good, a normal curve. All right. So what I want to do is, I'm going to do samples of 5. Then I hit 2. Okay, do samples of 5. And I'm going to see what happens if we randomly select 5 things from that. So 5 pieces of data from this curve. Boom, 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 boom. Okay, this is the average of them. Average of those 5.
Normal.
Good, a normal curve. All right. So what I want to do is, I'm going to do samples of 5. Then I hit 2. Okay, do samples of 5. And I'm going to see what happens if we randomly select 5 things from that. So 5 pieces of data from this curve. Boom, 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 boom. Okay, this is the average of them. Average of those 5. So we're going to do it again. There's the average of 10 are these 2 different ones. Let's keep doing it a little bit because I want to show you what happens. This is another 5, another 5. So if I keep doing this, we're up to 5 reps, so we got 25 up there now. This is for the population. The mean is 16. The mean of my 25 is 0, it seems, so that's not quite right. If I keep doing it, see I do it for 10,000. Oh, what does that look like?
Another normal.
It looks like another normal curve.
Put it on. We didn't do it 1 and 3. No. We need one more.
Thanks, Rick. So what I want you to do on this piece of paper,
I shall be casted upon.
draw yourself a normal curve, please.
I was playing reality.
Call it normal.
I saw that it has a spell on it. I was like,
I'm going to actually add in the little x and y axes as well, which we don't normally show. And then it's asking for mean and standard deviation. So the mean of my population is 16, and the standard deviation is 5. So I want to put those guys down. And now I want to see what happens when we do a sample size of 5, sample size of 10, sample size of 25. So a sample size of 5, that's what I got right here. If I do it 100,000 times, let me clear this. If I do it 100,000 times, what's that shape look like? Normal curve again. Notice for my, if I do it 100,000 times, I get a mean or a mean of 16, and I get a standard deviation of 2.23. So that's what I want you to put down on this sheet. So we've got a normal. The sample mean was 16, just like the population mean. And then we got a standard deviation of 2.23, which is different from the population one, which was 5. All right, now let's do a sample size of 10 instead. Clear that bad boy up. Still using a normal curve. Now I'm going to go, instead of n equals 5, I'm going to do n equals 10. So my sample size is 10. Again, if I just looked at the first 10, they're randomly pulling 10 data pieces. And that's the mean. Now let's do another 10, so now we're up to 20. And I keep doing that. These blue ones, this is the average of whatever the data is that just got pulled. So if I pull enough of these, if I pull 100,000 of them, what's it look like again? Normal. We got a mean of 16 again. Standard deviation is now 1.58. Something we're going to see about that. So again, we're normal. Still a sample mean of 16. But we got a standard deviation of 1.58. All right, there's a couple things that are going to come out of this. bear with me for a little bit. Let's do the last one. It asks for 25. Now it's going to pull 25 data points. So that's what it's doing. It's pulling randomly 25 data points. And then it's going to take the average of them. I pulled 25 more data points. They're different. It's going to have a different average probably. Boom, it's right next to it though, very similar. If I do this over and over again 100,000 times, this is what it's going to look like. If I'm doing sample sizes of 20, oh, this is 20. Same idea, but let me change it to 25 so that we can be consistent. All right, 25, do 100,000 of them. I get a normal curve. What's my mean this time? Can you guys see it or can't you? 16. It's 16. Standard deviation is now 1. All right. Now there's one thing that I didn't really point out. I want you guys to see if you can pick it out. When I went from sample size of 5, let's see, there's my sample size of 5, 100,000. Look at that normal versus the next normal. Sample size of 10. And then I got one more question for you. Now let's look at the sample size of 25 and tell me how the normal curves are different. Okay, let me do it again. Here's the sample size of 25. Kind of imagine that in your head. Here's the sample size of 5 again. What's different? We got a narrower curve when we go up higher. So here it's pretty wide. Let's go to 25 again. It's narrow. Just like Vayu's saying, the standard deviation, which is what we're seeing on this. The standard deviation is going down, which means it's getting narrower and narrower. So I'm going to have you guys add in narrowest. Narrower. It's getting narrower and narrower as our sample size goes up. Good. All right, so big whoop. I showed you a normal curve and the things look normal. Big deal. Now let's take a look at one that's skewed. All right, there we got a skewed curve. All right, this is one of the reasons what I'm going to show you today, the central limit theorem, is very important and very powerful. We're going to go back to 5. So let's get this down first. The mean is 8.08, and the standard deviation is 6.22, hopefully. Yes, it is. So let's get that down. We got a skewed distribution. Sketch it so that you can see what the heck it looks like when you're looking at this later. Boom, it's skewed. Skewed which way? Right, good, good. Mean is 8.08 for our example, and standard deviation is 6.22. Okay, Nigel, I can see you're on the edge of your seat. It's going to get exciting. It's going to get really exciting. Uh-oh, now I've picked it up a little bit too much. Here we go. 5. You know the whole idea, though it's kind of neat to watch. Oh, okay, they're largely coming from over here, which is expected. It's skewed. Let's do another side. The means are showing up here, though. Okay, let's see what happens if I do 100,000. So I'm going to do it 100,000 times, but my sample size is only 5. Ooh. What's that look like to you? Still a pretty normal curve. It's not really skewed. It's skewed maybe a little bit, but not a lot. It's kind of strange. I'm going to call it approximately normal. I'm going to abbreviate it. The sample mean, wow, it was the same as the population, but not the sample standard deviation. That was 2.79. Okay, I'm about to get excited. Here's 10. I'm going to go straight to the 100,000. It's looking normal. Okay, it was understandable when we had a normal population and we took the averages, the means, and they all had normal populations. But it's kind of strange when we get a skewed population and when I take a look at the averages or the means, and they come up with a normal population. That's a little bit strange. That's what I want you guys to get down. We've got a mean of 8.09 in this case and a standard deviation of 1.97. So now we've pretty much got a normal curve again. Very slight difference in our mean, 8.09. 1.96 is my standard deviation. Let's do it now for the larger sample size, 25. Boom. Nice normal curve. Nothing crazy about that. .08, 1.24. All right, so let me see if I can have this make sense. You give me a normal population, you give me a skewed population. I take a class of students and I find the average grade. And I put all these average grades together. It's always going to form a normal population. That can be very, very helpful. I don't know what the population of grasshoppers out there is. I don't know if it's a normal population, if it's a skewed population, but it doesn't matter if I'm using the averages of their arm lengths or the sound that they make, the average frequency or something. As long as I'm using the average, I know it's going to end up being a normal curve. Now let's get really crazy and see what happens if we do a strange one. So I'm going to need a volunteer. Okay, here's what the volunteer needs to do.
All right, I'll do it. I wasn't paying attention.
Custom. So you can, and here's how you do it. Any way you want. You can do it any way you want. So that's how you mess it up. Make a custom curve. This is going to be a Fibonacci curve. Did I say it right or no? Fibonacci.
Fibonacci.
Okay, okay, all right. Okay, is that good? Do you want to do it again?
I want to do it again.
Okay, all right.
That's the most creative you can be.
There you go. All right.
Take your time.
Yeah. We got all that.
Whoa.
That's so cool.
Whoa.
Oh, yeah, there we go.
Whoa.
Yeah, there it is.
There it
Is that
is.
good? Is that what you want? Okay, now, so what's really crazy is that does not look normal at all, which is appropriate because Brian did. No, I'm sorry. No, that's terrible. I didn't mean that. Okay, so this is not a normal curve, but look what happened.
Good, it's slowly.
Can I go with 5? No, I gotta start with 5 because it's on the stinging sheet. So let's get this down first because this I don't have down. 18.13 is the mean and standard deviation is 7.02. Try to sketch this out. Then write down the mean is 18.13, 18.13, and the standard deviation is 7.02. You're gonna need to feed that back to me in a second because I'm gonna forget those numbers. Okay, so 18.13, and the standard deviation? Thank you. Excellent. Okay. So the shape, to get the bit. Let's do for 500,000. Whoa! It kind of looks. So my prediction is you would show and Antonio will not.
I was wrong, too.
All right. So does somebody got that down? 18.15 for the sample size of 5 and standard deviation is